So with our Module 6 material, we finished 6-3, 1 through 3 on Tuesday. Any questions that you want to run by me before we look at the last couple of sections from Module 6? So we'll start with 6-4. Looking at percent increase and decrease examples. So basically, when we talk about percent increase, we're asking how much as a percentage has something increased from its original value. And let's take that first example to start us off, where we have a car's gas mileage increases from 17.5 miles per gallon to 18.2. So we go from 17.5 miles per gallon to 18.2. And we want to find the percent increase from here to here. Maybe we switched and took a road trip, so we're getting better gas mileage on the highway than in town, right? So what was our percent increase in gas mileage? We need to take the new amount, 18.2, and subtract the old amount of 17.5. That's our first step. And we can do that in our calculator. You might want to confirm for yourself that you get 0.7 from that. And then what we want to do with that as a next step is take that difference, 0.7, and divide it by the original amount or the old amount, 17.5. When we do that, we get 0.04. 0.04. So a couple of things you can just verify for yourself in your calculator real quick. Do I get 0.7 from this subtraction? And then when I use it, divide 17.5, do I get 0.04? Confirm those for yourself. And then I'll put our last step up here. We multiply by 100 to convert to percent. You can verify that in your calculator once you're ready. 0.04 times 100 gives us 4, and that is the percent equivalent. Also, moving the decimal twice to the right gets us there. Converting that decimal to percent, moving twice to the right. Another way of looking at that. 4% increase from this to this. What we just determined there. So let me write these down more generally. We're taking the new amount, subtracting the old or original amount, and then dividing by the original or old amount. Subtract new minus old, divide old, and then do some conversion of that to percent. But in summary, that's all we're doing right there. It could go the other way. We could go down, and that will be reflected in this subtraction. What do you think would happen if we went down some amount? The new amount is less than the old amount. In that case, let's look at an example. The second one on your paper there, which says, a production method reduced the time to clean a part from 8 to 5 minutes. What's the percent decrease? So cleaning time went from 8 minutes to 5 minutes. We want to take the new amount minus the old amount. What's that? -3. So when we go down, we get a negative sign. That's kind of an indication that this is a decrease. Then we want to divide that number by the old amount, 8, and take your calculator and determine what that is. You should verify that's negative 0.375. And then finally, we take that and convert it to percentage. So we have 37.5% decrease in that case. We went from larger number to smaller, so it's a decrease. As we report something like this, we might not include the negative sign, right? We might say there was a 37.5% decrease in time. Here we could say there was a 4% increase in fuel efficiency. So sometimes, even though we determine like positive, increase there, negative, decrease there, when we formulate it in words or put it in words, then the sign may no longer be necessary. If we're saying decrease, okay, that means it went down by this much. We don't need to report it with the negative sign there. And of course, it's implicit here, this was positive. Any questions on those? Feel like we can tackle those okay? You have a couple of practice problems that are similar that you can try from your paper, and then you've got your online options too. Okay. Let's look at 6.5 about markup and discount. Markup would be if we're in business and we obtain a good for a certain cost, but then we want to make some money off of it, so we put a sales price on it that's higher. We mark it up by some amount, some percentage of our original cost. So let's look at that first example from 6.5. We have a watch costs $98 and sells at $156.80. What's the markup rate? And so this works in exactly the same way as percent increase. We want to take the price we're selling it for. Let me write this down in the same structure. We have a $98 cost thing, and then we take it to $156.80. Let's think what that was. So it's exactly in the same kind of line as our percent increase or decrease problem. So we went from here to here. We want to first take the difference. Then that gives us $58.80. The amount that we marked it up. What's the rate? Then we take that $58.80, divide by our original amount, which is our cost, in this case, 98. And that will give us a decimal. Confirm for yourself. That's 0.6, roughly. What is it exactly? What'd you get? That's right. So it does work out to exactly 6.6. Then how do we convert that to a percent? Is that 6%? What is it? Is it? Is it 6? Or is it something else? Because our calculator gives us this, right? What do we do when we convert to percent? I'm going to take times 100. So we want 1, 2. Because 100 is 2 movements. So not 6, but 60%. Okay. You move that decimal on this, you introduce an extra 0 in there. Thank you for showing me your result on your calculator, because that gave us that opportunity to really think about that conversion and this step. If you're looking at one place past the decimal, you've got to introduce a placeholder or a 0 right there in order to report the correct percentage in the end. And just for our visual sake, 0.06 would equal 6%. See that? 1, 2, that's 6%. What? 600%. Let's look at that. For a reference, 600%. If we think backwards, 1, 2, our decimal goes right there, 6.0. Think about it the other way now. 1, 2, 1, 2. You have to introduce the placeholder there. Or if we were just looking at the number 6 and thinking about converting it. 1, 2, there's an understood decimal next to a whole number, right? We move twice to the right, we've got 600%. Good. Thank you for throwing that out there. I think all of those are a good reference to understand the back and forth between decimal and percent. This has a different percent than this. Based on the decimal form, we have to be careful in making that change to percent. I do want to offer also just the insight that if I take 6 times something, say I have say I go to a movie today and it costs $10. I think it costs more than that today, but say it costs $10 to go to a movie today. And 20 years from now, it increases by 600%. So it costs 6 times as much. It costs $60 if it increases by 600% over the next 2 decades, and it's gone up by this number of times. The 100% increase means it's gone up 1 time over. 200%, 2 times as much. 300%, 3 times as much. So that first example was about markup. We marked up by 60%. And let's look at discount, the amount by which the regular price is reduced. The rate is the percentage of the regular price. We have a gold ring with a regular price of $450. $15. And we are going to take 55% off. $55 off. What's the sale price? What is the sale price? So I'm sure some of you have some intuitions about that because we often try to do this kind of calculation when we're shopping, right? So you tell me how you might approach this, just kind of off the top of your head, what might you do? Yeah. So that sale amount, we could subtract off of here and get the sale price. I think that's kind of what you're thinking, London. So we need to do some multiplication and some subtraction. Very good thinking. Let's formalize that into a couple of steps. Let's look at the discount amount itself. Amount. How can we figure that? 55% of this, that's 415 times the decimal form of 55%. Move your decimal 12.55 and 415 times 0.55 gives us 228.25. Now what? Subtract like 415 minus, is that what you're thinking? 228.25. What does that give us? Got 186.75. Anybody else? Confirmed? Good. Now what is that number? That's the new price. That's the sale price after taking that much off of this. So that's it. That's what we were aiming for. Now, what if I just asked you for how much is it discounted? That's the amount discounted. $228.25 is the amount discounted. So I'm just throwing that in there as kind of questions that could be asked that we've already found the answer to kind of along the way. You're thinking a percent decrease, I think, maybe divide the old amount. Yeah, yeah. Good thinking. So try out the other problems for markup and discount. Let's talk about simple interest next. 6.6 is the section number. And we'll start with that first example you see from 6.6. It says, $12,000 invested earns $462 in 6 months. So 12,000 invested earned 462 in 6 months times the annual simple interest rate. And so we need to, for our reference, use interest equals principal times rate times time is the simple interest formula. And what these mean is this is the interest I earn. T is how much I invest, the original principal amount. R is the rate as a decimal. And T is the time, specifically in years. Okay. So what are we trying to find here? Find the simple interest rate. Which one is that in our equation? Which one is it? The R. We don't know that yet. We have to have all the other pieces though. So let's fill in the blanks. What's I? Interest, how much is that? 462. Right? 462 is the interest earned. Then what's P? $12,000. That's the original that I placed in the account. And then we can figure out T, otherwise we don't know R. What's T? Interest equal principal times rate times time. Time needs to be in terms of years. How much of a year or years did we invest in? 6 months. How much of a year is that? Half. Just in case it says 7 months or 8 months, let's just get in a mode to where we can write that fraction with any number of months. Place it over 12. We know there's 12 months in a year, right? And you told me 1/2, which is equivalent to this. Perfectly good. Just in case we get a weird number of months, like 7, we want to be ready to set up that fraction in some way. So if it says months, we can put 12 down here. If it said days, we could put 365 down here. Okay, then how do we solve this? 462 equal, well, what might we do? That's kind of like what we're finding, what we don't know. We could operate with these two. This is times everywhere here. So we can do this times part. What's 12,000 times 6/12 or 1/2? Try that in your calculator. 12,000 times 6/12. That's why I'm purposely not saying more. I want you to try, what would you do to try to simplify 12,000 times 6/12? let's let's make it, go ahead, London, what? Okay, that's a perfectly good way of doing it. So what London just showed is that the calculator sequence was 6 divide 12 equal, and then times 12,000. You can type that into your calculator. Try that, Jackie. You can also do 12,000 times 6 divided 12 equal. Okay. What we got? Mm-hmm. Okay. So Jackie got 6,000. Is that what you got, London? Good. 6,000. And then we still have that R because this is all we did. These two times one another. Either of these will work. I like um, I like this one so long as you don't have more going on down here. Like if it were 12 minus something down here, then this key sequence wouldn't work. Um, I like this one so long as you're not retyping in this number. You reuse it, whatever you see in your calculator, and you just start immediately typing in times 12,000. And it's referencing this answer. I don't want you to retype in that number. Does that make sense? So do 6 divided 12 for me. Go ahead, 6 divided 12. So that thing is sitting in your calculator right now. Now just do times 12,000. The reason I'm stressing that is because later on, if you do something like that and you have 0.873110 11, 9, and then you try to retype in that stuff, you might not want to type in all those digits, right? And so you get the wrong answer because you only typed in part of that information if you retype it in. That's why it's a good thing to get in the habit of when you can reuse stuff like that in the calculator. Okay, now let's think back to Tuesday. How do we solve this? How do we solve that? Any idea? Okay, if you're still not quite there, what would you divide? Remember, the goal is to get variables by themselves, numbers all together. Notice if we divide 462, that's what you wanted to try. Divide 462. We get 1 over here equal a bunch of stuff with R on it. So what do we need to maybe do differently? Let's maybe divide this off of the R. That way we'll have R here by itself. Divide same quantity over here. And that's going to give us a decimal, obviously, 0.077. and then we can convert to the rate. I think what might give people or give us some hesitation with that step is if this number is bigger than this one. So it doesn't feel natural to divide 6,000 on both sides. Right? We kind of have a preference to divide larger numbers by smaller numbers. Am I right in my intuition there? So that's why we might want to try dividing 462 on both sides. But we want to recognize the structure of these equations, variable here. So get rid of the stuff next to the variable is the objective. So we got to force ourselves to divide this really large number, even though it feels unnatural to do it with this smaller number over here. We get decimal result. All that feels weird, right? But that's in line with what we're finding. It's a rate. Let's convert it to percent. 1, 2. And we've got 7.7%. That's the rate of interest we earned. I'm just going to add on to this another question. What is the maturity value? And you see that's defined on your paper as M equal principal amount plus interest. Maturity value, also called future value a lot of the time. How much will you have in the future after making these investments? So maturity value is our principal amount plus the interest earned. Our principal amount was 12,000, remember? 12,000, and what was our interest amount? I of 462. Add those two together, and at the end of that 6 months, we have $12,462. That's maturity value in that particular example. We invested 12,000, earned $462 in 6 months. So at the end, this value is that amount. That kind of question is almost too easy to, feels too easy almost. More of an intuitive exercise, but I just wanted to throw that question in there. Since we have maturity value defined on your paper there, that could be a perfectly valid other question. Now looking at your practice problems, the second one asks for maturity value. So the second one, you would go through this process and figure out I, then you would add it to the principal. So that's problem number 2 there. Let's try number 1 on the practice problem. Practice number 1. We borrowed $15,000 for 90 days. $15,000 borrowed for 90 days. and the interest was 7.2%. And we want to find the simple interest due. Simple interest due. Okay. So which pieces do we have? Which place is appropriate for my 15,000 of these four? Principal. Good. Okay. Any other inputs I can plug in there? Yeah, so if the problem specifies it that way, instead of using 365, like I said earlier, just use 360. Where can that go? Which place? Time. Yeah. So I'm just going to put a placeholder there for R. And then what will we place for our time T? 360-day assumption, number of days in the year. How many days is this loan going to be? 90 days. So we've got to have at least one other piece of information. Which one do we have? Do we have interest or rate? Yeah, we have those two identified. We've got to have one of these others in order to solve. Which one do we have? Do we have I or do we have R? Yeah, we got that one in there. I or R. This we haven't used yet, right? So which one does that go in? The rate. And how do I want to write it? One, two, point zero seven two. When you move that decimal twice, it creates a zero there, so 0.072. And looks like we're looking for I. Does that make sense? Find the interest due. Yeah, that's interest amount reference. So this one's actually a lot easier. Notice we're just multiplying all these numbers on the right-hand side. So interest equals, let's confirm that we all get the same result. Take your calculator and try to do this multiplication. Okay, so you got one more multiplication. Say times Which number have you not used yet? Yep. Go back to the 90 minus 90 divided 360 for me. Go back through your steps. You need to press clear. See that first part again. 90 divided 360. And then you did times 0.072. Good. What did we get, London? What'd you get? What? 270? Good. All right. 270. So at the end of that 90 days, how much did we pay? $270 in interest. And we got to repay this loan, right? And we have to repay this loan, right? So altogether, 15,270. That's kind of looking towards that maturity value question again. How much all total? This plus this. For a fraction of the year, right? We did this for a quarter of the year, approximately, since we're using that 360 assumption. If we had taken this loan for a longer period, like a whole year, this interest might be about 4 times as much. Okay. I think that's a good place for us to stop today. And stop our recording.